All right, now let us actually begin. Thank you, everyone, for coming along to the IoT IRL information session with IT Masters and Charles Sturt University this evening. Thanks, everyone, for registering and coming along. This session will also be available to view later on as well. So my name's Jack. I generally MC the webinars for the short courses at IT Masters, and I'm also an eligibility assessment officer as well. With us this evening, we have Shane Murphy, who I'll introduce more thoroughly in a little moment, Jeff Jenkins, Dr. Geoff Jenkins, and Kit French, who also is my esteemed colleague at IT Masters. Before we officially begin, I'd like to say, first of all, that we are broadcasting, or we are presenting tonight from the lands of the Wurundjeri people of the Kulin Nation, and pay our respects to their elders and ancestors, acknowledging their unceded sovereignty and ongoing connection to lands, waters, and cultures. And a little bit of housekeeping before we begin as well. If you have questions for the panelists, for Shane or for Jeffrey, please direct those to the Q&A section, which is down the bottom of your screen slightly to the right. And those questions, we'll go through them. They won't all be answered, but we'll try and get a good cross-section of those questions in throughout the presentation and as well at the end to talk about the actual substance of the presentation. If you've got more operational style questions about IT Masters, enrollment, eligibility, courses, operational kind of things, feel free to direct those to the chat function as well. And Kit and I will do our best to keep you updated on those as much as we can. So we should begin. So our main speakers tonight are going to be Shane Murphy, who is the ITM Sales and Marketing Manager. And he has worked previously in the Internet of Things industry since the mid-90s in carrier and comms mainly. And we also have our wonderful guest, Dr. Geoff Jenkins, who is a network and applications engineer at Core Wireless, has been an Internet of Things developer and operational manager for over 20 years, as well as having many, many fascinating stories from his years in academia as well. Once again, my name's Jack. I am the eligibility and course advisor at IT Masters, and we also have Kit, who's going to be moderating with us this evening. So I believe we've got a little bit of an order of operations as well, which I think Shane is going to take us through. Is that right, Shane?
Oh, I will indeed. Hey,
brilliant. So,
Jack?
I'm very well, thanks, Shane. And I have a question for you. And my question is, what is the Internet of Things?
Well,
shall we get to that?
We'll get to that in a tick. But we're going to essentially, just so that everybody knows what's coming on tonight, and I saw somebody asking how long it's going to be. We hope to get it wrapped up in an hour. Sometimes we can get a little bit caught up if we get lots of great questions, which I'm sure we will. So we're going to have a little bit of a very intro to the Internet of Things, an interview with Jeff Jenkins, a little bit about what we cover in the Charles Sturt University subject, Internet of Things, which is one of the subjects available in some of our master's degrees, and then a little bit of this sort of nuts and bolts stuff about how you get into our courses and what you can do to, pay for them and get subsidies and all that sort of stuff. And there'll be questions. In fact, there'll be questions at the end of the interview as well, so that we can split those up into a couple of groups. And let's see if that works.
Now, I did jump the gun very slightly, but I am still very interested in your answer to the question, Shane. What is the Internet of Things?
Thank you. Drum roll. So, by the way, these quotes are from the two authors who wrote the textbook for the ITC 560 subject, and this is a bit of a take on the old Thomas Edison quote, which was, to invent, you just need a pile of junk and a good imagination, which is, I think, what everybody thinks that the internet is. Pile of junk. So we've cribbed this one from Wikipedia. The Internet of Things describes physical objects with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the internet or other communications networks. That says a bucket load, and it also says nothing at the same time. For those of us that worked in the industry for a very long time, really, I prefer to describe it like this, and I know that looks like a lot of boxes on the screen, but essentially there's 5 main components of any Internet of Things application, and I'm happy if somebody comes up with a question that can challenge the 5. Some might have slightly less, but it would only be simply because they're combined. So essentially, at the left end, we have edge devices. So these are the things that collect data or they actively do something at the time. So the sort of devices that we might see out there, what I call polling devices, there's things like vehicle tracking devices, which sense your location at any point in time and then send a message off, or they measure the height of a dam, the height of the water in a dam, and then send it off. Opposed to that are more active devices, and they're things like FPOS machines, which actually focus a transaction. And pretty much any edge device comes into one or two of those categories, even if it's a camera. Cameras are edge devices. Many years ago, we had an application which was microphones that recorded bat noises so that bats would not fly into wind farms. And that chewed up an enormous amount of data, but was a very successful application and a way of showing that you can use very simple technology in ways that aren't thought of before. So that's your first main area of it. It's the edge devices. And that's what a lot of what everybody gets caught up with, because they're the things that are ubiquitous. They're everywhere. That's what you see. The rest of the stuff is not really seen in so many ways. There's the connectivity layer, which historically came from this sort of area, from cellular and wider area networks, radio and other sorts of networks, because the Internet of Things started out as a thing called machine-to-machine technology. In the 80s, even the 90s, it was called all sorts of other things as well. But essentially, cellular and WAN were the great drivers of the take-up of internet connectivity, because cellular was the first technology we had which covered a wide area of most countries at relatively low costs and with the ability to send small amounts of data comparatively cheaply. Lots of people build private net radio networks as well, but cellular was the real driver of it. And that is, in fact, the industry from which Jeff and I come. We spent a lot of years in that, and Jeff is still working in that in the cellular form, providing connectivity to devices. Then over the last few years, in gaining in popularity has been the area of what I call PANs and bands, personal area networks and building area networks. So that's Wi-Fi or Bluetooth or Zigbee or some other form, usually of wireless connectivity within a limited area or a building or a site. So it's much smaller in range. Then you've got the other extreme, which is satellite, which again, Jeff can comment on a little bit more as we go on, because satellite is becoming more and more important for anything that can actually see outside a building. It's obviously complex inside a building, although we're finding a little bit more stuff does get into the building these days, particularly with assisted GPS. And then finally, there is still an amount of connectivity that happens down fixed wires, particularly in buildings. But it is something that we can't completely ignore, because some devices are just wired into place and they go. So that's your second component of it. It'd be interesting to look at the comparative costs of all of these things, because edge devices typically are a capital cost. This is an operational cost. And this these days forms data storage forms a ongoing cost as well, really, because nearly everything is stored in the cloud. But there are still a lot of people that store within their own circumstances, particularly with high security needs or with high privacy requirements. Governments will often do stuff in-house, although I think that AWS and Azure and those people are making huge inroads into that. So essentially, you're collecting information, you're sending it down a pipe, it's being stored in a big warehouse somewhere. Then you've got all that stuff in the warehouse, and to that you apply some business rules. And to be honest, while this is the smallest part of the diagram, it's actually the most important function in the lot, because it drives outcomes. Without the business rules, without business intelligence, IoT applications are, to a large extent, hobbies. And we've seen many ones where people expected to do brilliant things, and they were technically wonderful, but had no business rules associated with them. And the first business rule is who gets paid. But ultimately, that comes down to if X happens, then what do we do about it? If the dam level that we've measured over here gets too high, what do we have to do? We have to tell somebody so that they can either release the sluice gates or they can prepare people to leave the area if it's going to be a major flood. Because often with a dam, you can tell 3 to 5 days in advance of when the flood's going to happen at the other end, just simply by the level of the river. So there's all of those implications. This is critical. All the rest you can play with in different ways. This is the thing you can't change because it depends upon either money or saving time or saving lives. And then you've got outcomes, which are those things. You get alarms, something's happened, an alarm goes off, the dam level's got too high, you've been told that the driver's driven outside his area, the delivery's late, something like that. You've got a transaction. FPOS is the easiest one to do. There are other ones around, but primarily FPOS these days. And then you have reports. So every month, a building manager might get a report on the building usage of power right across the board, and then they can take other actions from those outcomes. So this is the whole ecosystem, really. There's not very much that extends beyond this ecosystem. And I think in the time I was working in IoT, we probably assessed, I don't know, thousands of applications, and most of them failed in this area. And the other area they failed in was the channel to market, but that's outside the actual ecosystem. That's how you actually get, applications in, but it generally came from a failure in the business rules. If you don't have a business case, you don't have an application. And that's what the IoT ecosystem is all about, really. The customer and the business process experts are where the application is really driven from. What has tended to happen over the past 20 years is it's these guys, the app developers and the hardware developers and the connectivity providers, that have actually tried to seed the market, and they've tried to drive uptake of applications. So it was the people who developed applications for using GPS that said, oh, we can develop a small GPS receiver, put it in a vehicle and send the information back, and then tried to sell it to trucking companies. That was one of the first widespread, more visible applications of IoT. But that wasn't necessarily driven by customers. In fact, the customers always said, oh, if only you'd made it $1,000, not $2,000. And then when it got to $1,000, I said, oh, if only it was $500. We'd take it up straight away. And the reality was they couldn't justify a business case for it in their own minds because their business process people hadn't told them how to do it, but it was being driven out of here. What happens now is you're getting much more of this area of the ecosystem driving what happens. And often the customer is the person involved in developing the app, purchasing the connectivity, contracting out the hardware development or doing it themselves, and also have a business process expert in-house. But without all of those roles being filled, nothing happens. So here's some examples of IoT apps in action, and I would assume that probably everybody who's on this has some idea about most of these sorts of things, but we'll just talk in general terms. There are dozens and dozens and hundreds of apps, but many of them fall into similar sorts of areas. These are the most used ones. Utilities. Here in Victoria, where I live, virtually every premises has a smart meter these days that enables the collection of real-time or near real-time usage data on your power meter, and it gets sent into a big data warehouse where the person who bills you is actually separated from the person that collects and sends the electricity to your door. They also use it to monitor and maintain their transmission networks. In payment applications, you've got parking, wireless FPOS, vending machines, all of those things. COVID has been an amazing boost to all of those things because everything is now wireless. I don't know if you people are using cash anymore because we don't, I reckon I've still got the same $50 note I had 2.5 years ago. In medical, there are more and more apps appearing in medical, and it's interesting to watch the what I would call the payment flow in medical happen because, for example, in sleep apnea, there has been a move to have sleep apnea devices monitored via the Internet of Things. And that is primarily driven by health insurance companies in America. What they wanted to know was that the people that they were paying for the sleep devices for, the CPAP machines for, were actually going to use the devices, because then their health insurance would be viable. And if they didn't use the devices, then the companies would refuse to pay for the machines. So it is interesting how it happens there. Fitness apps, Fitbit, all those sorts of things, your iPhone itself, your Google phone, they all have multiple connections for these sorts of things now. And diabetes, there is an app we looked at many years ago, which got, sorry, diabetes. I say diabetes every time and I'm thinking asthma. This happened to us the other day, didn't it, Jack? An Asthma Puffer. It had a tracker in it, and they could determine when you were having it. It was for children, because they discovered that if children didn't regularly take the puffer, then they were much more likely to develop worse asthma as they got older. If they actually regularly took their Ventolin, it was going to be much better. And it's the same with diabetes. Some of the diabetes pumps are actually monitored the same way. We've spoken about logistics, tracking, and dispatch. That was the original way that I certainly became involved in this sort of thing, through two-way radio networks back in the 80s and 90s, where you wanted to be able to automatically dispatch things because it was 10 to 15% more efficient. And that's just gone on and on and on now. Who does not get a delivery where it's already telegraphed to you when your delivery is about to arrive, and has in fact been derived, often with a photo attached as well? We couldn't imagine those things many years ago. Smart buildings is a hugely growing area. Again, here in Melbourne, I know that the local council has been keen to make what they call a digital twin. So they're building virtual copies of many, if not all, of the big city buildings, and ultimately want to monitor what goes on in them for fire, for parking, for health reasons, for energy levels, all of that sort of stuff. And parking. You've seen the parking signs around in every city. They are all interconnected in good cities, so that you know that there's some sort of central control around trying to manage the amount of parking that's available with the amount of cars in the city. And often, as in our lovely city here, with a determination that they are trying to reduce the number of cars in the city in the first place. And security was the other one, one of the core builders of IoT in the early days. Building access, building alarms, a rapid response. Security drove a lot of what's going on. And as Jasper's just said, yes, weather stations, all of that sort of stuff. So IoT has gone from being very much a fringe technologically driven series of apps into something that surrounds us everywhere. We could go on and on and on with applications, but I just wanted to give you just a general flavor of what it is, because I think rather than hear me just rabbit on about stuff, it's probably going to be good to speak to Jeff and talk about some of the things that are actually happening in the world. So I've spoken a little bit about these, but I think it's important to underline what's the purpose of having these applications, because I know there's a lot of concern about information sharing, surveillance, and other aspects of IoT and security especially. And so, the value's got to be there in order to do it. So for utilities, it's stopping things like brownouts, early warnings of problems. They're able to load manage the whole network properly, because they can actually see in real time what's going on. Before, they had to wait, when the meter reader came around, it'd be weeks or months before they knew how much power anybody was using, apart from the drain they were getting on their generators. And real-time billing and usage data is also very useful for bigger organizations. If it turns out that they've left the lights on in the factory all night, that costs them quite a lot of money. That's just a mundane, stupid example, but it is all of that sort of stuff that adds up over time. And a lot of what the Internet of Things applications do is they take very small amounts of data and build a picture over a period of time. Like every bit of data is a pixel in a very large picture. And it's not until the pixels get to a certain point you can see what the picture looks like. It's one of the ways I've usually thought about it. The other way is, of course, that in many respects, 99% plus of the data you collect through these sorts of applications is actually pointless and useless, particularly if it's something that's an alarm or something. But it's that very small percentage when the alarm goes off is what you really need to hear. and you have to collect the rest in order to get you have to collect the dross in order to get the gold, I suppose. Payments, we've talked about how COVID's affected that, and everything has become cashless now. It also refers to things like stock updates from vending machines, damage control, automated metering. All of those things would not and were not possible in quite the same way 15, 20 years ago. Medical one is really important, not only for the health insurance stuff, which is by the by and probably limited to places like America, but it's early issue detection. Ultimately, those results get back to doctors and they can track what's going on with their patient without having to have them come in every few weeks. They can track the responses to some of what's going on in the device. The CPAP machine might, for example, detect back pressure or certain other features of what's going on with the use of it that would indicate that maybe there's another problem developing. And so they can try and head that off at the pass and save everybody a lot of time, money, and energy. Fleet logistics we've spoken about, cities, effective use of resources, less power usage, and health. Things like Legionnaires, the safety of large cooling and heating stacks in buildings, all of that stuff is actually, again, really important. Usually find that safety things are amongst those ones where we collect a lot of data, but we don't actually use it until it becomes critical. And it's the critical thing, or the important thing, is to be able to map the patterns, so you can see if something's building up that's going to be a problem. Same with security. You don't really want to know all the time that the door's shut. You only want to know when it's open. And so part of the challenge of applications is designing them in such a way that they try and only send the important data across the networks, particularly if it costs money to send data across networks. And I thought, just to sort of close out this section, and Jeff was reminding me earlier, and I'll introduce Jeff properly in a second, that we've been seeing these sorts of graphs all the time I've been working in this field. Now, it's worth noting up front, this point here is when the graph was drawn, and that's the point at which reality turns into forecasting, or it says down here, I would take that as fantasy, because inevitably these graphs all have the same curve. They go up steadily in a very nice path, and then they rocket up for the next few years after the forecast period. And inevitably they do grow successfully. We're not talking about small amounts of growth. You're talking about 26% compound annual growth rate. That is a phenomenal growth rate in anybody's terms. But then they're talking about, it increasing further over this point in time. Currently, at the moment, they're talking in realms of 12 to 13 billion connected Internet of Things devices. However, that's defined by the IoT analytics people. And we're talking about doubling that in the next 3 to 4 years. That's probably optimistic. You probably find that the graph's going to go, more along the path and the trajectory is what it's going now. Why did growth slow between 20 and 21, Colin Phelps? It slowed because of COVID, because people weren't installing more things. That's generally what's happened. But you can see that these compound growth rates over here in the different connectivity forms, and they've used that as the way of doing it rather than by application, because it's fairly easy to break down. But even wired IoT, which is tiny, is still growing at a compound rate of 7%. Legacy cellular, which is what we nearly always use now, 3G, 4G primarily these days, it's growing at 17% compound rate. Wireless LANs are growing at 24%. Smaller networks, 22%. So we've got huge growth rates. And obviously 5G is growing at 159%. We could make a whole pile of jokes about it being due to COVID, but let's move on from that as well. But yeah, just give you a feel for how ubiquitous and how important this is as an overall sector in information technology. And to be honest, how little it's been looked at to date. So I thought I would introduce Jeff today to you. I've known Jeff for many years. Dr. Geoff Jenkins has been involved in IoT since 2000, when he stopped becoming a lecturer in ancient history. and other subjects. He's currently a network and applications engineer at Core Wireless, but he's been inventing applications and designing things since 2000, and probably before that a little bit on the side as well. He's designed and implemented a number of connectivity applications for satellite and cellular in his current role and in other ones as well. And I believe he plays a lot with Raspberry Pi and other applications on the side. And he's fluent in a pile of ancient languages. We've said a dozen. I'm not sure whether we could get him to tell us all of them, but things like Syriac and Aramaic, their ancient forms, are languages that he's been teaching in. And Jeff's ideal working from home situation is the oasis pictured here, and that is Jeff himself some years ago at this oasis where there is an ancient site that his team were excavating. So he'd love to be working from there and doing his apps at the same time as we're doing things. So I'd like you to welcome him along with me. And I thought we'd say hello, Jeff. How are you?
Oh, I'm good, Shane. I'm good. I'm reminded of so many conversations we've had over the years where you said that's a good idea, but what are the business rules? Where's that going to go? Who's going to pay for it? And we had quite a few of those, didn't we, in our conversations?
Yes, I think you got sick of me saying that, and it's one of the reasons I took a little bit of a break from it for a while, because I got sick of saying it. We had people with great dreams and not very clear ways of getting them in place. But tell us a little bit about what you're doing these days. I see you're standing in front of an old castle as well as your backdrop. Is that at the same place that photo is from?
About 10 kilometres. Away, but that's half a day because it's wind-blown sand and very slow going to get from one to the other. That's a little place called Umadabadi with a 2nd century Roman fort.
Excellent.
So you introduced me as a network and systems applications, perhaps, engineer. These days, I'm a pre-sales engineer. So they keep moving me around, but it doesn't change what I do.
I was going to say, does it make a difference?
No, the labels is a bit meaningless. Pre-sales means that I need to engage with customers, not just with machines. But I think I always did that because I was always interested in how the technology could be implemented to produce a good outcome for a project. So I've always thought about machine to machine and IoT as very much an ecosystem which involved people. We probably shouldn't think about IoT as Internet of Things so much as using things to enhance people's experience, enhance environment, and help us to, I think, to live better lives. And that personality aspect, that real people, real machines part, a full ecosystem, I think is something that has become clearer and clearer as I've done this more and more. So
yeah, I like to think of it as helping us make better decisions.
Yeah. Oh, that's a great way to express it. I think that's true.
So maybe let's talk about some of the sort of applications that you might have built and what sort of difference they've made, because that sort of extends on from what you're saying.
Yeah. So what I didn't just disclose, but I should, is that I've been a hobby programmer all my life. And when Shane and I first started working together, it was on the assumption that I would write some applications which would somehow enhance the business that Shane was doing. And we did that right from the start, Shane. We raised the hood and we wrote applications. We wrote a radius server right at the start. And that helped us to discover some applications of the radius protocol that we didn't know, I don't think, and weren't popularly known.
It was interesting because, and just to extend from that radio server, when we first started that business, it was a very small business competing actually with the larger cellular carriers. And the radio server, for those in the call who understand what that is a very simple, in some respects, piece of technology that just assigns an IP address. But what that actually enabled us to do as a small company was to be extraordinarily nimble and to be able to set up applications that could do things straight away. So in those days, people required static IP addresses because their application design wasn't great. And we were able to deliver static IP addresses overnight, same day, straight away. And it really worked. And I think that's an example of, a very small and not especially groundbreaking application, but done in a very simple way that had a huge difference to what we were doing.
And another one that you'll recall, Shane, is application of SMS. So it was that large sleep apnea company that needed to be sending SMSs in particular ways and particular circumstances and to particular markets. And what we built there, a hobby piece of application really, but that supported what was a very substantial business for quite a few years. And interestingly enough, SMS is a good example of it, isn't it? That's a technology that we all thought had its day. But now it's in use in IoT very widely. And what we discover is that SMSMO, especially where you text, I don't know the answer to some number, and back comes a response, that sort of application, which we worked on years ago, has now become ubiquitous. So these things go in and out of favor, but the foundation protocols that define them, so the Smpp protocol for SMS, capable of supporting lots of actions that we don't even use most days, SMTP for email, but these days we're using email within IoT contexts. So a quick example of that is we've got, we do some Iridium and we do it together with cellular, sometimes packaged in a single device because Iridium is very expensive. Cellular is much cheaper, but cellular doesn't work everywhere, whereas Iridium pretty much does. We like to say that if you put an ATM on the South Pole, you could get money out of it using Iridium. And weirdly enough, even if the ATM was down a crevasse, you could still get money out of it using Iridium. It mightn't have much of a business model, I don't think, Shane, that one.
I suspect not. But for those who don't know, Iridium's a network of global satellites originally used for phone calls that Motorola and a whole pile of companies put up in the 90s and has come into its own as a primarily data network with a small amount of voice across it these days.
Mm. So what we've built, even in the last short while, is a technique for switching between Iridium and cellular networks. So we have customers who will always, their device will always use cellular because it'll be maybe in the Florida Keys. They're only interested in satellite if someone steals the yacht and sails it to Cuba. So for a whole lifetime of the application, they'll never use any satellite, but they'll be paying a significant fee for it. So we designed a technique for monitoring the cellular network, and when it went away, we would switch on the Iridium.
Right.
And those sorts of benefits, ways of bringing different technologies, different streams together, that I think is probably a focus of what we try and do to enhance IoT.
I would, at the risk of being, banging on about it, I would suggest that that's an application of business rules driving an application for a change, rather than the technology. Those technologies have been around for ages, but the business rules haven't been there.
Yes.
What do you think of the core skills that people working in IoT these days need?
Well, your Venn diagram of sorts, Shane, earlier on with at least 4 areas of interest. And I noticed a couple of questions which we might come back to later, which really add to the 4. And probably nobody has all 4. So in terms of where I come from, I think imagination, interest in raising the hood is the key to how I approach IoT. So in particular, IoT demands database skills, and pretty much everybody involved with it needs to be thinking about the storage of the data, how to merge streams into a single database, how to analyze the data, AI or whatever it be, how to share the data, and I add another one, how to cycle that data around to users who can then plow back their insights into the way in which the data is structured. So all of that, I think data is especially important for IoT.
Yes, and
a lot of it.
Yeah, I know that Charles Sturt also have a big data subject, which is available in a couple of our courses as well, and that is a very nice marriage with the IoT sort of stuff. I would also say that, you know, from my experience, and I have no technical experience whatsoever. I too have a classics and English degree, and have never gone down the technical side like Jeffrey, but I would say it's about asking the right questions of people and particularly when you're trying to engineer something, because often it's not about being able to decode the Python or whatever that it's written in. It's about being able to say, well, there's a problem here and there's a problem there. Therefore, the problem must be coming from over there in the stream. And and I noticed that somebody's asking about how to become an IoT professional. I don't think yet that we're just starting to see the emergence of those sorts of professional sort of recognitions for somebody that specializes in IoT. That's coming a little bit late to the party, because it is so many things like networking and cloud computing and cybersecurity are all involved very intensively within IoT. It's a real mix of all of them.
And everybody, Shane, I think, who's working in IoT needs to think about the wide ecosystem and to say there are all these different elements which are essential to a good IoT project. I don't know about all of them, but I know that they're all important. And then I can participate usefully in the conversation with a customer, with a friend, that produces a good project design.
Yeah. So what's coming up next, do you think?
Well, satellites is going to be important for the future. We've talked quite a bit about Iridium, or mentioned Iridium lots of times tonight. And that's just because where I work, we've been doing Iridium for 10 years, and we've got lots of satellite customers, but they're all using Iridium short burst data. But Iridium has already moved on to not short burst data, but a Certus IP-based product. And then in the meantime, we've got Iridium's a sort of small truck of a satellite, whereas something like Swarm is a shoebox or a wine bottle of a satellite. And that's
a lot better if it crashes to Earth.
Yeah, well, indeed. And that's changed all of the way we think about satellite. It's reduced the cost very significantly, and it's changed the applications in the very process. So there are only very few applications where people could afford to use Iridium. So large, heavy transport, tracking, that sort of thing, particularly if there were compliance issues, all of that would justify using Iridium. But wells around the Great Artesian Basin, that we couldn't track each of those. We couldn't monitor each of those. Now we can do that with Swarm, and we're doing it.
Right. So I'm getting, and we're about to move into questions as well. But the first question we're getting is about Starlink, and it keeps coming up. Oh, that's Musk. Right. I'd not heard of Starlink. I must have been living in a shell. Do you know much about Starlink, Jeff?
I don't. I know a lot about Iridium, Shane. And I know about Swarm, but there are four. Are there four or maybe five major heavy-duty satellite networks? Inmarsat is the most common one that people think of when Iridium is mentioned. These are heavy-duty systems, particularly for monitoring aircraft. They have major military applications. Can I quickly mention, Shane, to change the subject for a sec, because I can't answer that question. We've got a great Iridium customer who flies drones for delivery of medicines, and they're all around the world these days. But we were with them just 2 years ago, right at the very beginning. Their CTO is a good friend of mine. We sat down and talked about how such an IoT project could be built so that you could fly your drones from his beach house at Mount Martha. It's moved on since then a great deal, but it's a great project. It's Iridium, it's cellular, it's Bluetooth, and it's all over the world.
Yeah. It's interesting. I see some of the comments about how Starlink is much cheaper than Iridium. And I mean, I don't know how necessarily true that is. I'm not questioning that's the case. But I think what we found with things like Internet of Things applications is the difficulty has been to be able to purchase airtime on any network that takes account of the fact that you're only using very, very small chunks of data a lot of the time. So that you might, Starlink might be very much cheaper for what we might use for web browsing or running a call or all of that sort of stuff. But it's a lot of the ones that are very cheap on high bandwidth data are very expensive to use for small data. And when you've got a lot of, if you're deploying thousands of devices around the world that send kilobits, if not, bits of data every couple of hours up, they generally don't meet the requirements for a high bandwidth product. Plus also the hardware, it becomes an issue then as well. But it'd be interesting to see how Starlink goes. I will say that my inherent cynicism is that nearly every satellite network that's gone up, with possibly the exception of Inmarsat, because that had a base in maritime and health and safety, generally went through Chapter 11 bankruptcy 3 to 10 years after it was put into orbit, and the people who then took it over made all the money out of it because the technology was there and working, and they were able to reprice it, so it was much more sensible. So it'll be interesting to see how Starlink and all the other ones come along. So what have we got here in terms of questions? Somebody has asked, where does administration sit in an IoT landscape considering the 5 components? I think administration can sit in a number of different places. Generally, it sort of sits in some respects with where the business rules are, because that's where the energy is developed from. So whoever implements and manages the rules is the person that manages it, because IoT is such a group of disparate things usually brought together. The management is very complex, I would call it, because you're often dealing with different vendors for hardware, for software, for connectivity, and all of those things take time to manage. What does happen though is it tends to develop companies that are good at integrating all of those things, and then that company manages the process. But usually that admin will sit somewhere either at the databases or in the business rules or the outcomes, because they will usually happen around the same spot in some form or another. What other questions have we got? Is Terminate Sky the next IoT? I think we'll leave that one alone.
Well, Shane, I was going to use that question actually to pivot into some of the really interesting things that Jeff was saying to us yesterday about the way that a lot of the questions around IoT are less technical and more legal and infrastructural and geopolitical. So rather than the specific Skynet question, thank you, anonymous attendee, I suppose the question is around what, Jeff, do you, or Shane, do you see as the kind of future of IoT data collection and distribution, ownership and use of the data that's being collected, some of which is very, very useless currently, but much of which is potentially being stored and may become more useful in the future.
Jeff's still on mute, so I'll have a first crack at some of this stuff. It's quite scary, I think, in some respects, but in others, you have to have some faith in what remains of the systems, and it comes down to trust. Who are the people we trust to have this data, and do we trust that they're going to do the right things with it? I know we've all heard the stories of Google search using anonymized data, but that being able to pinpoint people who, for example, wanted to inquire about terminations in some Midwest town in America where it wasn't allowed. And so that they're the dangers of unfettered data access, at an unfortunate level, not at a malicious level. Obviously, malicious attacks are another problem altogether, and security in IoT, I think, is going to be the great challenge of the next 5 years in every single place. But politically, it's about who do we trust, and are we going to allow them to have the data, and are we going to compare that with the data that people already have on us from using any social media network in the world, using a mobile phone, etc. How we know that data is going off to commercial organizations already that have no, only have minor implications about how they use the data, even though they are slowly being impacted. What do you think, Jeff?
So it really intrigues me how sometimes the most valuable data we don't get access to. It's not shared with us. And my favorite example of it is the in-home display for electricity use. That information was collected ostensibly so that we would all have access to it, and we'd be able to change our behavior, use a bit less electricity, or use it at a more sensible time of the day or night. And in fact, back in the day, people said we can build fewer power stations if we get this right. So it had really important ecological implications, the best use of that data. I don't think it was shared with us. Ostensibly, everyone was going to have an in-home display. Everyone was going to be included in the discussion. It didn't happen. It was political as much as anything else.
Well, yes, the history of climate change and renewable power in Australia is a whole political narrative of its own. I should just mention at this point that a couple of people have been putting their hand up, which we don't necessarily respond to. So if you could, if you get a chance to type a question, that would be really good.
So carbon monoxide, Shane, for a moment. We had a mutual friend who thought to himself when they built a freeway next to him, I should start monitoring carbon monoxide levels and monitor them right throughout the period of building and operation of that freeway. So that was a 10-year project, anticipating that data set would have value. But I've picked up a son-in-law in my wanderings recently, and he's an airport designer, systems engineer, and he collects data sets. He doesn't collect them, he buys them, of wind direction, wind speed over a 10-year period in a certain location, which somebody has collected, and then they've said, well, here's the data you need. You can't make your decisions without it, especially with climate change and the like. Somebody thought of that in advance. And I think that's where data is the key. And it's the opportunity for us too, to discover that, build our own data sets and share them.
I think it depends on how well you protect the originators of the data from identification for purposes that they may not have wanted. One of the really mundane applications of what you're saying is, I don't know if people know, but one of the ways that Google Maps and the like are able to give you traffic data is that they buy the real-time traffic data from just about every courier company and taxi company in the world. And they push that through their back end and they measure where it's going, and they have developed long-term maps of that together with some predictive algorithms. When I first started in this industry, working for Vodafone, actually, there was a mathematician who lives in Mount Waverley. He had developed a comparative model that from 6 o'clock in the morning, he could tell you how long it was going to take for your commute on the local freeway into the city, which is normally a 25-minute commute, depending on the traffic that had happened by 6 a.m. that day. And they're the sort of algorithms that have gone on. But it's buying that data, as you said, Jeff, that people have been using for other business rules and being able to reapply it in a generalized, de-identified way that has provided value to everybody. I know I use Google Maps all the time in order to be able to get around and try and find the fastest way. And then I have a little game with myself to see if I can beat it, because that's one of the things. Jeff, do you know about the ITIL network framework? Somebody has asked the question about finding value and co-creating value, and they're all in that net framework.
Really, Shane?
Okay, we will. I'm sorry, anonymous attendee, we'll have to pass that up because I don't know that framework. Is there a curriculum in development to learn and apply IoT? If so, when can I start? And will this include? Well, there isn't. There is and there isn't. So we have one subject which we're about to go into and just give you a little bit of information on. And if you were looking for an IoT specific set of subjects, we would be happy to have a chat with you about how to derive that by doing, say, a master's in network engineering or something similar to that. It will have a lot of industry certifications, which is part of your question as well. This is Jeff Black's question, but they will not specifically be IoT certifications, because as far as I'm aware, there aren't a lot of IoT specific applications, and Jeff's shaking his head to agree. So what I'm going to do now is move on and say thank you to Jeff for that part of it, but please hang around and feel free to drop your thoughts in as we go on. We're going to move into the last part of it now, or second last part, which is to talk about our subject. This is run out of Charles Sturt University. It's a part of our online degrees. The Internet of Things. The subject is ITC 560. And this quote is from one of the gentlemen who wrote the textbook for that subject. So how the Internet of Things will bend and mold the IP hourglass in the decades to come, will certainly be fascinating to witness. We as engineers, developers, researchers, business leaders, consumers, and human beings are in the vortex of this transformation. I think while that's a little bit florid, it does give you an idea of what's going on. So ITC 560 is designed as an omnibus subject, is what I would call it. It is a very wide-ranging structural look at the Internet of Things from an academic point of view. They cover pretty much what we used to call from DC to daylight. Everything that you can think of with IoT, they've got subjects on. They have areas on blockchain. They have areas on communications protocols, the way that an application will go together, some stuff around business use cases, a couple of weeks on security, architecture, and some of the history around those things. And therefore, it's designed to give you a real taste of the Internet of Things. One of the reasons that we're running this webinar tonight is to try and ascertain if there is an appetite out there for people to do more in-depth things on top of this subject. So you would do this subject as an introductory fundamentals of Internet of Things topic, and then maybe take a further subject that has a deep dive in one particular area, for example. So it is a very wide-ranging subject and has a lot of stuff that you cover in a 12-week period. So as necessarily, I believe there is a very small amount of coding. There is a project of some sort, but you'd have to look more at the handbook, Don. I've just answered that question as well. So to give you an idea, here's the learning outcomes for IATC. That's probably a really good way to explain what's included in the course. Be able to explain and demonstrate the various components of an Internet of Things. Well, we've partly done that already. Be able to analyze the role and importance of IoT in the modern world. To be able to investigate and propose various requirements of an IoT application for the real world. Be able to evaluate a variety of existing and developing architecture technologies. and to be able to describe and evaluate different applications of the Internet of Things. So I think that gives you a very good feel for the sorts of things that the course is going to give you and the subject's going to give you. It's I think there's a lot more that you could go into in particular areas, and we will talk a little bit more about that when we get to the end of the next phase of our discussion, which is about how to study these sorts of subjects with us. And I'd like to invite you back, Jack.
Hello, it's me from earlier. Yes, so thank you very much for all of your fascinating insights and information, Jeff and Shane. And if you are, like me, interested in learning more about Internet of Things after hearing from them, like Shane just said, we do offer one specific subject currently with IT Masters and CSU called Internet of Things as part of several of our degrees, which we've been delivering online since 2002. So if you're not currently familiar with IT Masters and CSU, we have been an entirely online delivery provider since 2002. There's no need to attend campus to study any of our courses. And we do try and provide a large amount of really dedicated student support from IT Masters. We have dedicated session support officers, administration staff. There's myself and Anna who do eligibility and credit assessments, as well as, just an ongoing kind of network of mentors and subject coordinators as well to support your study. We are the largest, or we were the largest provider of online IT degrees for about 4 years up until 2020, when basically all universities, it became necessary for them to provide online degrees. And we have been a leader in the market for a really, really long time. Our graduates have some of the highest earnings and the highest rates of employment in their desired field once they've graduated out of any of these higher education providers in Australia.
It is quite surprising because Charles is rated towards the bottom of the university ranks for, overall as it is a university, but in the IT area, Charles is rated very highly and the outcomes for graduates are very high.
Yes, yeah, absolutely. And part of the reason for that is because of the approach, like with IT Masters, where we tie in industry-based instruction and industry study with the pure academic study. So that actually leads us really well into this pathways to study. So essentially what we want to do is recognize that, especially in the IT industry, there are a large number of people with high levels of technical expertise, experience in the industry, who it would be like sleepwalking to go into a certificate 3 and 4 or a bachelor's, but who don't currently have formal tertiary recognized qualifications. A lot of people have industry certifications. I've seen people in the chat talking about Cisco, CCNA, CCNP, etc. There's a wide range of those, and we allow entry into the postgrad program through our graduate certificate pathways for people without a previous university level qualification. If you have relevant work experience of a certain amount or relevant industry certification as well. So if you've got a bachelor's degree or if you've got that kind of hands-on industry certification or experience, then you may be eligible not just for entry into the graduate certificate or master's if you have an existing degree, but also course credit. So we provide a lot of recognition of RPL, recognition of prior learning, talking about being able to gain subject credits so that you're not redoing exercises and information, relearning information that you know backwards in your sleep. So some of these providers that you can see on the screen now are just some of the organizations that we recognize certifications from across a variety of our degrees. These are the degree areas that we offer study in. We provide graduate certificates, master's degrees in all of these subject areas. We also provide a graduate diploma in project management. And like I said, those graduate certificates can lead you into the master's. If you have an existing bachelor's, you can go directly into the master's. But yes, particularly the career computing career transition, if you're not quite sure where in the IT industry you'd like to get into, then you can articulate once you've finished the graduate certificate into the full master's degree. And as I mentioned earlier, we allow you the opportunity to shorten your study time, as well as reducing your financial burden of studying with course credit. So industry certifications, prior postgrad qualifications. If you've got an existing postgrad degree, we will assess the subjects that you studied against our subjects to see if any of them cross over enough to provide you with credit. Australian Computing Society certification as well can provide course credit. And then we also have our free online short courses, which are delivered in a very similar manner to this webinar, actually. And we'll just be putting a link in the chat as well to our free online short courses. If you successfully complete and pass 3 of those, then we award you credit for 1 subject.
It may actually sound a bit counterintuitive that we're saying here's ways you can shorten your degrees, but we've come to the conclusion over a long period of time that there's no point trying to teach people things that they already know as much as we possibly can. And we're very keen to get students on board. We'd rather have students on board that do 2 subjects and get a graduate certificate than people who say, oh, I'm not going to pay for all of those subjects I've already studied. So this recognition of all the industry certifications is critically important for us. Because it is the people that do our degrees are largely people in industry working already and who just want to get ahead in their lives and learn a little bit more about the areas they're working in. Sorry about that siren in the background. They're not coming to take me away, I hope.
Excellent. And so to follow on from that as well, there are a variety of funding options. So there's quite a bit of government funding being put towards these types of subject areas at the moment. All of our courses are available if you're an Australian or New Zealand citizen or a permanent resident of Australia under the Fee Help program, which you can find out more at the link that is currently on screen. It is a low interest federal government higher education loan program. Alternatively, you can pay your subject fees up front. If you're currently working in the industry and your study is relevant to your existing position, there's a very high possibility that you may be able to claim some of your course fees towards your tax as professional education. And many employers as well in the industry are quite happy to subsidize education, professional development for their employees as well. And currently for the rest of 2022, we actually have a number of our graduate certificates specifically that are eligible for the Commonwealth Job Ready Graduates Package, which is a program under which you would be able to get a significant amount, up to 71% of your course fees covered by these Commonwealth supported places in these 4 subject areas. That can then articulate into a master's degree if that's where you want to go, or or alternatively, the graduate certificate is a fantastic standalone certification. And just really quickly, I'll answer a question that I've just seen pop up in the chat. The online master's degree, it's not actually accepted by Australian immigration if you're looking for a student visa because it's studied online. I would direct you, if you're looking for a student visa, towards some of Charles Sturt University's other relevant degrees that would be able to be studied partially online and partially in person, and that would confer eligibility for a student visa. But online-only degrees are unfortunately not available for that.
Exactly. And we're going to close the questions down in a sec as well. So if you've got any last questions, bung them on the list now. We're into sort of the last slide or 2, and you'll notice we've picked up the pace a little bit because we have been trying to fit everything into roughly an hour, and the Internet of Things could go really forever with what we're doing here.
It is quite an extensive topic. But I'll just drop the link now in the chat as well. If you are interested in finding out whether you're eligible to study or eligible for course credit, you can fill out our eligibility form, and my colleague Anna and I will assess your eligibility to study with us or get course credit and get in touch with you via email or phone. Alternatively, if you just have some questions about eligibility or questions about any area of the course and the ways in which we deliver our study just basically about how IT Masters and Charles Sturt University work, feel free to give us a bell at eligibility at itmasters.edu.au or on the number that's currently listed on screen. And we are very happy to have a chat with you about the potential postgrad study options for you.
Yeah. And I will also say that in answer to the question before, that if you wanted to try and create an IoT specific degree out of what we've got, that's the way to get in touch via that. And I'd be certainly happy to have a chat to anybody as well. But yes, so now we're going to run a little poll. Are you ready for that, Jack?
I am.
Just to see if anybody would be interested in hearing more about different IoT areas.
So these are the, I've launched this poll now. So we'll take about 5 minutes or so, or 2 or 3 minutes really, asking which areas of IoT would you like to learn more about in either a short course or a subject? And you can select more than one. So we've got IoT applications or apps and business cases, smart buildings and cities, security, connectivity, or other. And if you are interested in another specific kind, feel free to put that in the Q&A section just before we close it.
That'd be great. And now we'll while that's also going on, the poll, let's answer a couple more questions. I did see somebody has got up here, the home connectivity application area seems to be a big growth area in IoT. What do you think about that, Jeff? Have you been coming across that sort of stuff in your field?
Well, as it happens, we have a new large customer here who, together with the university, has built a home security application, which does a whole lot of meter reading and other bits and pieces in conjunction, and has sold it to a number of local councils. So that's the big picture and the small picture. The scope of it is in individual homes, but the application is sold to local councils, and they look like being very successful.
Yeah, and that's not even mentioning, Google Home and all the Alexa stuff and everything. Yeah, I think it is going to be huge. I think there are, valid concerns that people have about privacy and security, but we will work around some of that over a period of time, or people will accept that some of the data is going to be used. I don't know. It's going to be very interesting to see how that plays out. Like a lot of these areas, the people in the industry have been aware of them since 20 years or so ago. The technology has been around in most cases for all that time. In some cases, it's been too expensive until recently. In other cases, we've just had resistance to uptake. And the best example I can give is something different but related is video calling. When 3G phones were introduced and we all thought video calling was going to be the absolute bee's knees, nobody took it up. Nobody made video calls, partly because of the pricing, partly it was complicated, all sorts of other reasons. But the reality was it was so useless that they pretty much turned it off on the networks. Then all of a sudden, FaceTime, Zoom, all of those technologies have come along, and now everybody uses video calling all the time. It's ubiquitous. We're used to it all the time. It's very interesting. And it's the same thing with things like home use of IoT applications. Something will happen that will spur that along. We don't really know what it is at the moment. It could be climate change related applications. It could be power usage. It could be something else that will spur it and make it actually tip over the edge. That's my opinion on it anyway. Here's a question about which I'm going to be honest and say I don't understand the question, and I'm not sure that I can answer it, but let's try anyway. What do you think, Jeff, and maybe you know the answer, what do you think about the risk of global disruption given increasing dependence on widely distributed IoT systems, e.g. Kessler syndrome, exponential satellite collisions?
Oh, I thought we were going to have a poll on that, Shane. Oh, but someone's asked that question. I missed that. Well, I think that there can't be any doubt that when you put anything online, then it's exploitable in some way. I suppose the protection in a way for IoT is that there's huge amounts of data, and corrupting a little bit of it's probably not going to produce anything serious. Disrupting the networks that carry it, might be serious, but only, I suppose, if it happens to disrupt the key datum that you're trying to communicate. And that's not going to happen by accident.
Yes, you would think that if those vulnerabilities were that exploitable, that we might see more of it being used in an aggressive manner by players such as Russia and the Ukraine at the moment. You would think that they would be itching to look into that. This is more a comment. Sounds like anything that's computerized, has data, is connected online is IoT. Therefore, is a phone, a PC, an IoT device? Unequivocally, yes. You might be connected to the other end of it, so it's not personless, but the reality is that that device is doing a lot that you're not aware of all the time, particularly your phone. GPS, movement information, it's tracking which websites you go to and sending that information back, although you are more in charge of that now with various phone manufacturers having implemented the ability to turn it off. The phone manufacturer themselves is recording information about how you use your phone, where you use it, what times you're using it, where you've been, COVID apps, are tracking all of that sort of stuff as well. So unequivocally, yes, all of those devices are IoT devices, anything that's computerized and has a connection. And, that we all laugh about smart fridges and things like that as being useless, but over time, those things will happen, I believe. And I think we've got, I think we've pretty much got one last question, which is, can all these technologies be merged to help humans in disaster management? I would sort of suggest they already are, but the problem is that disasters being what they are, often the technology fails at the time it's needed most. But what's your experience with that, Jeff?
Such a fundamental question to ask all our customers, which is, when it's needed, how can you be sure it will work? And we've got medical alarms which have never sent a message from 1 year to the next, over 5 years, and all of a sudden the person falls over. No one's sure whether that's going to communicate or not. It's a very poor design, and really everything that is contingent needs to be tested every day.
I think that's the answer, is continuous testing and continuous working. I know that the people like the fire authorities here in Victoria, because of the bushfires some years ago, developed multi-communication pathways for virtually everything they do. So the fire authorities have their own radio networks, the police have their own radio networks, the AMBOs and the Metropolitan Fire people have their own networks, and they have several mobile command centers that talk to all of them in theory. And of course, when you get towers collapsing, then a lot of them move into satellite mode. But obviously in Northern Rivers, where Jude is, that did not happen at the time that the latest floods were in, and that is unfortunately what happens. And it's every time there's a disaster, it's what we learn out of it. We always seem to be fighting the last disaster in arrears, and we learn from the previous one, but we don't necessarily expect what's coming up in the next one. And that's where strategic implementation of your aims is the critical part of it.
And Jude's question reminded me, Shane, of the number of cases where river monitoring devices went underwater. And they were never going to work. You hope you got a message just before they gurgled away.
You would think that if they all went off at the same time, though, that in itself is a message which says, I've lost contact. It reminds me of, we used to have rules of thumb for when things went wrong in our networks. If one person called me then with a problem, they owned the problem because it was their problem somewhere. If I got 2 or 3 or 4 people calling me in a very short period of time with a problem, we knew we had a problem and we had to do something about it. And then we went on to narrowing down, asking the right questions. Where's the problem coming from? What's the symptoms? Where does it happen? In something like a major thing like the Northern Rivers floods, obviously the people up there were underprepared, I would imagine, for what was going on, because in theory, once in 100-year floods, which doesn't actually mean you'll get the floods once in 100 years. It just means there's a 1% chance of them happening in any year.
And you
And I-
remember that other dictum, Shane, make sure that you know a customer has a problem before they know.
Yes, amongst many others.
I think we are pretty much about ready to round out the evening currently. I know that there's quite a lot of interest in having some pretty ongoing discussions, it seems, in the chat and things about these questions. So I thought I'd just really quickly share some of the results from the poll. We've got the majority of people, it seems like a lot of people are interested in all of these different aspects of IoT, but the largest cohort is in security. So IoT security, which definitely raises, was raised in questions quite a number of times. And then next highest was in the IoT apps and business cases, followed by connectivity, and then at the end, smart buildings and cities. But there was a large amount of interest in all of those. So thank you very much for that information. That will help us very much in, the development of future short courses and subjects that we may consider running in the future at IT Masters and Charles Sturt University. Thank you everyone for coming along tonight. This session will be recorded. It has been recorded and it will be uploaded onto our YouTube, the link to which can be found in the chat currently if you scroll up. And once again, feel free to let us know if you have any other questions by emailing admin@itmasters.edu.au, getting in contact with us that way, filling in the eligibility form if you're interested in finding out about your eligibility for study or for postgrad credit as well. And a big, big thank you to Shane for helping present this, and also to our wonderful guest, Dr. Geoff Jenkins. And thank you very much, Kit, for your administrative and technical support as well. Thanks, everybody, for coming along. It was a pleasure to have you. And would anyone like to say anything else before we head off?
I'd just like to reiterate your thanks to Jeff and yourself and Kit, and look forward to seeing everybody at the next one. Or then, by the way, we are running a short course on ransomware for security interested people in about 3 weeks or so. But thank you very much. And thank you for calling me a doctor, but I am not a doctor.
I'm so sorry. Well,
no, not yourself.
Thank you, Dr. Jeff.
Ayub as on the messages.
I thought I may have misspoken.
No.
Only Dr. Jeff in here tonight. Thank you, everyone. Have a lovely evening or morning, afternoon, or night, depending on where you are. And hopefully we'll see you in another one of our courses in the future. Thanks very much. Ciao.
Night.